My name's Tom Bascom. I'm with White Star Software. I've been doing this stuff for 30 some odd years, and I am one of those independent people. I do not work for Progress, so if I say anything, I'm not promising it on Progress's behalf. And I don't have any long, boring slides introducing you to my life history. So what are we here for? We're here to learn about client-server performance and networking and how that works in the Progress environment. We're going to talk a little bit about why we care about that, what network messages actually are, how you can go about improving your existing code, why find first is not the solution to all your problems. That's actually just a pet peeve of mine, but I'm going to spend a few slides on it. How to tune network messages to get better performance, and then I'm going to summarize it all. So, why do we care? Well, obviously, because Windows fat clients rule the world, right? And any of you who know me know that that's my most important criteria. Okay, maybe not. So some of the reasons that I think we care about client-server networking performance are because shared memory connections are not always possible. You have environments where you have multiple servers involved, you have distributed computing, you've got to make client-server connections to your database, whether you like it or not. Sometimes that's just corporate policy. Some large corporations just won't let you put any code on the database server. Database server is an island of its own, and there's no code running on that server, no matter how hard you tell them it'll perform better. If you're getting into the PaaS-OE world, resiliency in the PaaS-OE world is being provided by Docker containers that you can start and stop and put on different machines and move all over the place on a whim, pretty much, which means you're going to have a client-server connection. You're not going to have a shared memory connection. If you're streaming large amounts of data, as opposed to just onesie-twosie finds and whatnot, then actually client-server performance can, I know I never thought I would say this, but it can actually be faster because you only take that latency hit once, and then you're streaming the data. You have two different machines working on that stream at the same time. So in the end of the day, it actually gets done quicker. Another reason is that app servers scale differently from database servers. That whole issue with too many CPUs is not a problem with app servers like it is with database servers. You have very different considerations in how you want to configure and architect an app server environment than a database server environment. So those are all reasons why you really need to care about client-server networking performance, because you're going to have to do it eventually. Anybody got any other reasons that I forgot that I should add to the slide? Nobody? Nothing? Okay. Wow. So the core of client-server performance in a Progress environment is something called a network message. So what is a network message? Well, when Progress runs over the data, runs over a network, it takes the data, packages it up into something called a message. The client makes a request of the database. That's either a find statement, a for each, an open query, or a SQL 89 embedded select statement, something like that. It's asking the database for some data. The server is going to resolve that query. It's going to put that data together, and it's going to send it back to the client. When the client gets the data, it might decide that it has to upgrade locks, so another message is going to have to go back. And then eventually, when the client is done with the data, it's going to release the cursor. So messages go back and forth between the client and the server to do all these things. It makes for what you might call a chatty protocol. The messages themselves can potentially be broken up by the TCP/IP layer. So if the message is bigger than your MTU, your message, what's the T stand for? Yeah, message transmission unit, then it gets broken up into multiple packets by the TCP layer. So you have even more fragmentation going on. A single round trip from your application perspective may only take a couple of milliseconds. If you go out and you find a customer record and bring it back, that doesn't take very long. But if you have thousands of clients or many, many requests that you're making from the client to the server, that can all add up very, very quickly and become noticeable to the end user. During peak periods, some very large applications can actually get to the point where they swamp the network interface, not from a bandwidth perspective, but from the number of packets that that network card can handle. So your networking people may be telling you, oh, you got plenty of bandwidth, but you've run out of packets that the card can handle. That can happen sometimes too, and that's really disconcerting because now you're arguing with the network people. So Progress also has a special kind of a message called a query. So a for each statement, anything that returns a set rather than a single record, is considered a query. So a for each, an open query, or a SQL 89 select statement does query types of queries or messages. And what's special about those is that they can return more than one record. A find statement will only ever return 0 or 1 records. But a query, a for each or an open query, something like that, could return hundreds or thousands or tens of thousands of records. And making those more efficient is really the object of what we're going to talk about here. There are some very, very specific rules, though, about how you have to code and put things together in order to get the benefit of multiple records coming back in a message. Find no lock is kind of your prototypical example. So you find customer where the customer number equals 10, no lock. That's one round trip to the server and back for the record. And then later on, there's going to be a message from the client to the server that says, OK, I'm done with this, release the cursor. So you have 3 messages going across the network to do that. For each no lock, by default, is going to fetch the first record with 1 round trip. And then it's going to return as many records as it can fit into the message buffer in the following round trip. That's by default. Now, there are some rules, like I said. There's a maximum message size. That's the parameter. By default, this is 1K, which is pretty small. That was a really large size back in 1985, but it's 2019 now, and 1K is a really small message. There are also a set of parameters called the prefetch parameters. Prefetch delay says, skip that fetch the first record and send it right away phase. Basically says, put a bunch of stuff into the first message. Don't send me just one and then send me the rest. Prefetch factor sets the percentage full that you want the message buffer to be. So if you set it to 100%, it's going to try to fill that buffer to 100%. Prefetch numrex is sort of, instead of a percentage, how many records. And they work together. If you don't set the number of records, you get the default, which is 16. 16 records is not very many records. If you don't set the factor, then it'll try for 100% unless it's overridden by the number of messages. I'm sorry, numrex. So potentially, with a for each, you can send far fewer messages for the same amount of data, but you've got to maximize these various parameters in order to get an efficient transfer there. So how do you go about doing that? Oh, yeah, wait a minute. We've got to talk about some bad stuff first. So if you do a for each with a join and a sort, that's usually a really bad thing. So you can write a for each customer no lock, each order no lock of customer by ship date, for instance. And that's not going to work very well because it depends, first of all, whether the sort is on the inner or the outer table and what version of Progress you're running. So if you're running something prior to OpenEdge 12, those joins are really quite inefficient. If you're running 12 or higher, then you might get some advantages, and we'll talk about that some. And you may find that it's more effective to write it like this, nested for eaches instead of joined for eaches. Can sometimes be more efficient. And there's some trickery you can do with temp tables as well. So if you can do that outer loop with a temp table instead of with a real table, then you can get some real efficiencies in joining this stuff together. So usually, if you're in older versions, you want to try to avoid joins in a client-server environment. They may make really good sense in a shared memory environment, but not so much sense when you're client-server. So how do we go about improving our existing queries? Yep. Does anybody here have a brand new application with no legacy code at all? So yeah, you've all got legacy code. You've all got existing queries. You all got stuff that needs to run faster. Well, first thing is to pick your battles. So there's this thing called Amdahl's law. which basically says that improving the performance of something you don't use doesn't really get you a whole lot of benefit. So you want to focus your improvements on things that you're actually using. The code that runs the most is the code that you want to pay attention to. You don't really want to pay attention to something that only gets used once a year for 5 minutes. Or in other words, well, that is basically the same thing, but it comes down to the big queries that return a lot of data. Those are the ones you want to focus on. In your typical application, everybody's different. We all have different applications, but it's very common to go out there in the world and kind of look at the application and see that 80 or 90% of the requests are coming across as find statements, and that maybe 10 or 20% of them are queries or for eaches or something like that. But those queries and for eaches return a lot more data. So even though there aren't nearly as many of them, a much larger portion of your data is probably coming across in those for eaches, in those open queries, and those sorts of things. Unless you're doing something really crazy. And we'll talk about some of the really crazy stuff. So there's some simple things you can do to your existing queries that take hardly any effort that will improve their performance. A fields list. So if you don't need every field in the record, you can tell the for each statement or the open query which fields you actually care about. So if I'm doing a for each customer and I really only need to know their name and their account balance, then just ask for that. And that reduces the amount of data in that record that's being put in the message, which means more records can go in the message. And that's going to speed things up. You can either explicitly list the fields, or you can say, except for this one really big notes field or a photo or something like that, which is very handy. You'll get a runtime error if you goof up. So, try and do it right. There's also an option called cache, which sets the size of a client-side cache. Allegedly, the documentation says the default is 50. I'm not sure I believe that, but I haven't been able to prove it. Rich has asked me for some details, and one of these days I might get those tests to you. But define the query queue for the customer, give it a fields list, and say, I want to cache 1,000 records on the client side. And that will make it so that you don't have to go back to the server as frequently. There are some things that hurt a lot. There are some things you can do to your queries that will absolutely hose them. So if you accidentally have a share lock in your query, so you say for each customer, : you've got a share lock. You may not have meant that, but you now have a share lock, which means that instead of multiple records coming back in that packet, each record is going to come back in an individual message. You're not going to get the benefits of packing more things into a message. It's very, very easy to do that, and there's no simple way that you can just compile with cross-reference or something like that and find all your share locks. It's not that easy to do. You have to use something like SonarQube or something like that to do analysis of your code. And the impact, as the slide says, it can be 100 times worse, or worse than 100 times worse. You're really, really, really screwing up your code if you get an accidental share lock in there. Bad where clauses. The bane of the DBA's existence is the where clause that doesn't have an index that supports it, so now you're doing a table scan. Nesting and joins, like we talked about a couple of slides ago. If you have those going on, that can really cause some performance problems. And the can do function. Does anybody use can do? Now, can do is a security function. It is not a string manipulation function. Back in version 2 and version 3 of Progress, the lookup function did not exist. And so a certain very famous Progress partner discovered that can do was sort of like a string function, and they could use it to do things that are kind of like lookup. And their code base was very heavily influenced by this. And thus, all the programmers ever since then have learned to use can do to look up a string in a list of comma delimited strings. That's not what it's for. It doesn't work very well at that. It's a security function, and because it's a security function, it runs on the client, which means that all of your data has to come back to the client to be evaluated by the can do statement. That's not good for performance. It also has some behaviors that you might not be aware of. There are certain magic characters. There are things that will break when Progress makes changes to the infrastructure, like when they added the @ character as a magic character in can do. It started breaking a lot of people's code because they were using a security function for string purposes. You should use lookup, not can do. Yeah, okay, so that's all I really need to say about that. Stop using can do. Another thing that's a pointless waste of time is find first. If every time you type find, you also type first, you're making a mistake. That's not helping you. It's the knee-jerk find first. It's not that find first is always wrong. It's when you always use find first that it's wrong. I'm going to spend a little more time on this. So it's not a standard, it's not a best practice, and it doesn't always work. Yes, that very same famous application partner uses it everywhere in their code, and lots of other people's code is full of it. That doesn't make it a good idea, and it doesn't make it something that you should do. The idea behind find is to return exactly 1 or 0 records. And 99.44% of find statements should be for unique records. That's, by the way, the purity of Ivory soap, if nobody knows that. And it's, for those of us who are 4GL programmers, this is one of the things we really like about the 4GL. You can use a find statement, you go out, you get 1 record, you don't have to do SQL selects and result sets and all that SQL stuff. And if the where clause specifies a unique index, like it should, 99.44% of the time, then the find first, the first is not adding any value. It's not doing anything to help your code. And it confuses programmers like me who read that and say, oh, okay, there must be a second record. And I start looking for, okay, what are we doing with the second record? It's not faster. It doesn't eliminate a check for an ambiguous record. That's a myth. It only does that if there is not a unique where clause. If you have a unique find, which you should most of the time, and most of you do, then there's no difference between find first and find. It's not faster. It doesn't save you anything. It doesn't make anything any better. You can run this test code and you can test it yourself. It won't make a difference. All right, what else do I want to say about that? Not much. So you heard me say that. You go back, you test some code. Oh my God, that find first is like 10 times faster. Tom's wrong. No, Tom is not wrong. Your code is wrong. That means that you don't have unique criteria. Your where clause is not a unique where. You're either missing something in your where clause, or your where clause isn't doing what you think it's doing. So you've got a bug, or you have a likely bug. And what you're doing is you're returning the wrong record faster. So, you know, your code can be infinitely, or it's infinitely more wrong, something like that. So you went ahead, you did it anyway. What are you doing about the second record? Are you doing something with the second record? If you're not doing something with the second record, then you're creating a magical record. But anyway, back to the, if you do have a second record, what does first mean? First in what order? How do you know what the order is here for the first, second, third, fourth? If there is an ordering, what does this mean for the third normal form definition of your data? Is this properly normalized data, or are you doing something funky? If you happen to have a do while true loop or a repeat loop and you're doing find next, and you're going through the whole result set with that, why didn't you use a for each? And you would be very happy if you used a for each, because it's going to perform a heck of a lot better than this, and we'll get into some benchmarking on that in a little bit. The other thing programmers say is, well, it always works. And what they usually mean by that is that it makes it so that they don't have to deal with this message that you get that more than one customer record was found. So yeah, it always works. I don't have to deal with the error. Well, that error is there for a reason. You really shouldn't ignore it. So maybe you forgot a component in the index. I had an issue with some code once. A programmer was writing a delete routine and going out and finding a particular record and deleting it. He left out one of the components of the index, and he was using a find first to find to fix this problem here. So he was always deleting the first record of a set of various records that, had he used the proper unique combination of things, he would have got the third record or the fourth record or whatever, the proper one that he was supposed to delete. It took customers a while to notice that, but it was a lending system, and various borrowers were randomly disappearing. So, you'd set up a loan, and they'd make a change to it, and they'd want to delete borrower 3, but borrower 1 kept disappearing. It's not really good. Or it could be that a previously unknown feature has been enabled by the users. A lot of people in older systems have something like a company code to establish multi-tenancy. And in a lot of their deployments, and in particular in their development and test systems, there's only one customer. So a lot of code works really well until somebody starts using it in that multi-company mode. Then you find out you have these records that are not doing what you think they're supposed to be doing. Okay, so there we go. Then the other thing is you have a magic record. So if your data is not properly normalized, you might decide, well, I'm going to store the default value in the first record. So you put the default discount in the first record, and then you just always find first, okay, that's the default, and use that carrying on. Well, if something happens and the first record is no longer the first record because you inserted another one with a lower number or a lower name in front of it, then all of a sudden all kinds of stuff starts breaking. That's a magic record. And those bugs are really, really hard to track down too. So, summary of Tom's pet peeve about find first. It's usually a sign of lazy programming. It doesn't improve your performance. It creates bugs that are really, really, really hard to find. And just because your source code is infested with it doesn't mean you should keep doing it. Now, on to network messages. Now that I've got that out of my system. So, in order to kind of get an idea, get a handle on what your performance is for client-server messages and queries, there are some VSTs that you can use to measure this. In particular, the ACT server VST is going to tell you what the activity on a particular server is. And in a test environment, you can assume, if you set things up correctly and you're the only user, that server ID equal 2 is going to be the one where your client connects to. And this does work as long as you're the only user of this database. Otherwise, you have to go to a little bit more trouble to figure out which one the right one is. And you can have a test query like this. This one will work in any database because I'm using the underbar field table. And I'm just getting the field names. So everybody has a database with a schema. You've got a list of fields. The fields have names. This code will work for anybody. You don't have to have a special database. And you can just display these fields out of underbar ACT server to get the number of query records sent, and then do some division to find out how many queries you received, how many records were involved, and how many records per query. So this one up here, we stuffed 174.18 records into each quote-unquote query. Remember, a query is a multi-record result set from the database engine's point of view. We had 22 queries in all, so not bad. We stuffed 174 records into each one of those. How did we do that? We'll get there. Another way you can do it is you can download ProTop. ProTop is free to download. We have some commercial stuff, but you can get it from our website. And it will interactively tell you the queries received, the records sent per query, and the total number of records sent, either for the system as a whole or for individual servers. So you can see it in real time and see how efficient your efforts to improve things are. Or you can look at the graphical portal, which is even more fun, and see pretty pictures of stuff moving up and down. So here we see that. It's always more exciting. I'm told that I have to show pretty pictures and stuff. If you want to write a little test harness, you can do that. Do some include files and put your little test program here. So declare a couple of variables. initialize things. So we get the initial values from activity server, we put them in the variables, set the time to yes, so we start the timer. Then we run this is after you run the test, kind of how long did it take and what did we get, and spit it out to a report. Slides will all be available later, so don't try to scribble this down. And then this is writing out the report format. And now for the benchmarks. So I ran a bunch of benchmarks with that code that you just looked at. Just changed the coding in between the test code to do different kinds of for eaches, different kinds of find statements, different combinations of coding things. Okay, so before we get into the benchmarks, I got to warn you, benchmarks are just benchmarks. My machine is my machine, it's not your machine. So you are strongly encouraged to run your own benchmarks, to get your own code samples, to test it in your application using the sort of things that work for you. If you're uncomfortable doing that yourself, I am available for hire, so is Dan, so are several other people on our team. We'll be happy to help you out. Oh, wait a minute, there's a little bit more. It's also very hard to write meaningful benchmarks for this kind of stuff. You go and you put it together and you run your tests, you get a result, and it's just, that doesn't make any sense at all. Now you have to dig into it and figure out, why did it work that way? What happened? What did I do right? What did I do wrong? It can take weeks to get together a good set of benchmarking data for this kind of thing. One of the really tricky parts of this whole process was getting a network that was slow enough to actually show the difference between the client-server traffic and the local host traffic. Because if you're just doing a little test setup, you've probably got a server here and a server there, and you got a 6-inch cable in between them, and it's probably a 10 gigabit connection or something ridiculous like that. So it's way too fast. It's not realistic. So getting a realistic setup takes a little bit of work. So baseline test code, what we're going to test here first is the impact of the prefetch parameters. So the baseline is just running against the Sports 2000 database, get for each customer, for each order line, and iterate that 10 times. And that's 190 some odd thousand records. So that's enough of a data set that you can actually measure how long the time takes and start to get some meaningful comparisons. If you don't do enough comparisons and some of the values come out so small that you're within the noise of the measurement capabilities of progress. Yeah. It could be a typo. That might have been 410.
Well, you may be getting the template record and some other random stuff.
I may be getting the template record and some other random stuff.
There'd be 3 template records in that example. That's not
1, 9, 10, 14, 15, and that is divisible by 3. So that makes good sense. Excellent. Thank you. But that's a great example of how difficult it is to do this. So I ran these benchmarks. I thought I had good data. Somebody in the front row immediately sees a problem with my data. Okay, so we ran that with a bunch of different options for the prefetch parameters. And what I'm most interested in is, well, prefetch and message size combined. What is the impact of changing the message size? So 1K being the default, 4K, 8K. I also did 16K and the maximum, which is 30,600 or something like that. And then each of the prefetch parameters in turn to see which ones of those actually have an impact. So there's an eye chart over here. If you look really carefully, you might be able to figure out what's fast and what's not, but I've done you the favor of charting it. And basically what it comes down to is increasing the size of the maximum message has a nice impact if you do that and you add in the prefetch factor 100 and the numrex very large. And numrex is really the one that has the biggest impact. If you do some more detailed benchmarks and try number of records, 16, 32, 64, 128, you quickly come to the conclusion that small numbers are not useful. Use a really big number, and that will get you somewhere. And you get about a 40% improvement when you add everything in with a larger than default message size. Either 4K or 8K doesn't really matter all that much. If you go too big, if you go on the extreme end of things, the 32,600 size, then you start to lose a little bit of the benefit. So probably you want to keep it in that 4 to 8, maybe 16 kind of range. Yeah. The data that I tested. Your data may be different. Yes, in the back.
Can you set the num records too high?
I don't believe so. So the question was, can you set numrex too high? And I could not find a value that I thought was too high that caused any negative kind of impact. It's just you won't be able to get more records in. So personally, if it was up to me, I would make the default something really large, like 30,000, and I would always fill them 100% full. I can't understand why you wouldn't, but yeah, make it match MM. Good point. You'll never get more than that in there. Well, but what if you start compressing them? I'm going to be ready for the future. All right. Oh, wait a minute. Sorry. That's on localhost. So I'm doing the loopback network here. We're going through the network stack, but we're not actually going out over a wire. This is all within the same server. So you may have a situation where you have an app server where you want to connect to the database. You're all on one machine, but you're using client-server connections to do it, not shared memory, because these parameters don't apply to shared memory. So on localhost, we get about a 40% improvement. When we actually put it out over the wire, so we're on the network, we get about a 35% improvement. But the time that it's taking is much longer. So this is 20,000 milliseconds. This is 850 milliseconds. So actually going out over the wire is obviously going to be much more expensive than doing everything internally. And you don't get the severe penalty from having a packet that's too big here, because the extra work that's going into that is being swamped by the network time. Okay? So you still either 35 to 40% improvement by using the prefetch parameters to their maximum capability. Then I wanted to test various coding styles, changes, options in your for each statements. Things like adding the field statements, adding the cache, various things like that. And again, we come up with an eye chart, but you can quickly see that there are some things that have a lot of messages and some things that don't have very many messages at all. And these are, this is basically your objective, is to have a small number of messages and to have much more efficient, less chatty traffic. And again, I'm going to have some charts, but bad code is things like for each share lock, for each with a join, or using find next to process a large set of records. So the impact of a share lock, if you're in shared memory, it's going to cost you about 35%. So that's still pretty bad. That's not something you want, but it's nowhere near as bad as it is with client server. It's about 15 times worse when you actually do that client server, either localhost or over a network. The reason this column is so much higher is because your baseline is also much higher. You see the baseline for each no lock is much larger here, just like it was in a couple of slides ago. So you get a much bigger impact, much more noticeable to the end user. If you do need to lock records, so if you're doing share locks because you're doing an update or something like that, and you're just lazy, you don't want to write exclusive lock, you should get over that habit. Put an exclusive lock in there, adding exclusive lock to do those updates rather than just letting the share lock upgrade is about 30% faster. Because when you actually update a record that was share locked, it has to be upgraded to that exclusive lock in order to do it. So you eliminate that by just getting the exclusive lock in the first place. The joins. So in the shared memory environment, if you do a join, then it's probably about 65%, or at least in this data, slower than it was to not do the join. Client server is not 15 times worse, it's only 3 to 6 times worse. So, okay, that's good. Again, the network versus local host is more noticeable because you're starting at a much higher threshold. However, in OpenEdge 12, the impact is a lot better, or a lot less bad. Let's put it that way. That's because there have been some improvements made in OpenEdge 12, particularly server-side joins have an impact here. So the server side is able to do joins now in OpenEdge 12, which in 11, 10, 9, it never did. So you do start to see some improvement from that improvement. And there are some additional things that may be coming along. Remember, I don't work for Progress, so I can tell any lie I want. But I'm expecting some improvements to come in 12.1 or 12.2, where what's currently happening when you do a join, so you do for each customer, for each order line, you get down to order line, you're only getting 4 or 5 records per message coming back because it's broken down at that lowest level to send things back. But if more than one record can be packed into that message, more than one record type can be packed in that message, now you start to get bigger messages again. And that's an improvement that I'm expecting, well, from my conversations with people, expecting to see soon. So we'll see bigger improvements there. Find next. So if you're doing a repeat, or you do a find first, repeat, find next, find next, find next, or do while kind of thing, then in shared memory, again, it's relatively minor. It's about a 20% worse than just doing a for each. But client server, that's 8 to 17 times worse, depending on which set of code you're looking at here. And again, network versus local host is going to be a lot more painful. I did not bother to test for each with a find next with a share lock. I just thought that was going a little too far. Probably could have done a share lock and a can do just to really. But I'd probably still be waiting for that test to finish. Okay, open query. So this is sort of the bad code section. Open query is not bad code, but what happens when Progress rolls out new features is they have a philosophy of failing fast. So they want to get the new feature into the wild quickly, so they do the easy stuff first. And the static for each is kind of easy to do. Open query is a little bit more work, or so I'm told. So open query comes in a later release. So right now, open query is not as well supported as for each is, but going forward, probably in the next service pack, open query will be covered as well. And you can see this a little bit with 10.2b. So here, open query did not have the prefetch features available to it in 10.2b, so it's much, much worse than 11.6 or 12.0, whereas, but once open query got covered in version 11, then it all flattened out and everything was more even. Okay, so some of the things you can do to improve code, to write better code, are the fields list. There's an option called forward only on a dynamic query, and the cache, or those were things I wanted to test. Let's put it that way. Adding the fields. So when you add a fields list, you're actually going to make your shared memory code a little bit slower because apparently Progress has to work a little harder to make those decisions. But things do get a little bit slower for shared memory and localhost when you add a fields list. On a network, though, it was 45% faster. So you have to know where your code is going to run to make that decision, or if your shared memory code is fast enough, you don't really need to worry about it too much. It's not that much slower. And the reason that you get that benefit is because you're packing more data into the message. Thank you. You're packing more data into the message, so obviously it's going to depend very heavily on how many fields you're able to eliminate, how tight you're able to make that data. Your data is going to behave much more differently than my silly little Sports 2000 data. Forward only is an option to open query that basically says if you don't need to reposition backwards, then the query is considered a forward only query, and we don't have to build a result set, a scratch file for that, and it gets a lot quicker. Basically, if you're not using the query with a browse statement, then there's a good chance that it's a forward-only query. If you are using it with a browse statement where people might reposition things, then you're probably not going to be able to do this. But that's generally a fat client thing. That's not something you're going to do with app server code. So if you can add forward only, then you can get pretty significant improvements. Cache. That was a bad idea. Sometimes cache seems to help, but I couldn't come up with a test case that worked for these particular benchmarks. So try it yourself, but in my examples, it was very, very painful. I don't know why. And I ran out of time to figure it out. If you combine fields, lists, and forward only, then again, it's 10 to 20% worse for shared memory, 5 to 10 times worse for localhost, 7 times worse for OpenEdge 10 on a network. But if you have OpenEdge 11 or 12, then it's 45% better. So version dependent on your environment. So you got to know what you're doing, and you got to know where you're going into. Nesting and joins. So this is some sample code of nested queries versus joined queries and how they behave. And it's particularly bad if you have ugly sort criteria on the internal nest. I'm running out of time, so I'm going to fly through this stuff. And then you can do things with a temp table. So if you cache a small outer table in a temp table and then join on that, you can get radically faster results. So if you're going over say a subset of your customers, maybe 100 customers, put them in a temp table first, then get their orders. Everything will be much quicker if you do that. Use app servers. Put your app servers close to the database server. Try to eliminate going over the wire if you can, or if you have to, at least have it be a local wire. You know, nice short one's good. It's 1 nanosecond per foot is what it costs you to go over a wire, plus all the circuitry and the controller cards and things that are involved in there. Don't forget that. Very, very fast networks. So if you've got gigabit networks, 10 gigabit networks, something like that in your data center, then you're going to start to see performance that approaches shared memory performance, because those networks are very fast compared to what we had to work with 10 years ago. App servers behave differently than client-server networking. App servers stream the data back to the client. They don't send it back as records in the same sense that the client-server protocol is doing that. So to sum it all up, it's becoming a lot more important to pay attention to this, because your architectures are changing. You no longer have the very simple legacy character application that runs in shared memory. The fat client window application is becoming a thing of the past. You're now getting into distributed environments where you have PAS-OE servers that are starting and stopping in Docker environments that basically mean you have to pay attention to this. You have to know where your code is going to run and what your options are to improve the performance of that code in order to be effective in the future. So there you go. Any questions? Yes?
Ticker with SQL performance compared to
Sort of. So there were some tests of the internal SQL 89 stuff, which basically is a for each under the covers, and basically proved that, yes, that is what's going on there. Some of the impetus for this was that SQL performance has always, or not always, but for a long time been very strong compared to some of the 4GL performance. And I wanted to kind of poke into why that was and what you could do to get kind of in the same range with your 4GL queries. But I did not directly compare SQL 92 benchmarks to these particular benchmarks.
Any historic preferences you have as to one performance the other?
Well, depending on your version, there's going to be some significant differences. Like TableScan, for instance, has been in the SQL engine for ages and is really only very new in the 4GL engine. The SQL engine also has the cost-based optimizer versus the static optimizer for the 4GL, and that can make a big difference too. Again, it's going to depend a lot on your particular data and how you're accessing it. But SQL can be a very viable option, particularly for reporting kinds of things. Other questions? Well, thank you very much.